Hi guys, happy Tuesday, May the 5th, and you know what Tuesday means. It means it's lab day. It's lab day. So, come on up. Let's work on our lab today. What we're going to be talking about is the circumference of a circle. And hopefully you remember what circumference is. That's just the distance around the edge of a circle, and it involves pi, and it involves radius and diameter and fun terms like that. And so we're going to be reviewing a little bit of how that works, and you're going to be working along with me. And I'll show you what you need to work along, and you'll be just like before when you showed me a little something, took a picture of it, emailed it in. That's what we're going to do, so you can show me that you're following along. And after that, we're going to have an IXL, which is linked down below in the s'more, of course. And it's working on circumference too, and you can use a calculator on it. Don't worry, all this stuff is calculator active. So I think it'll be fun. So come on, look over my shoulder and I'll show you how it works. Here's what we'll need today. We'll need a couple pieces of paper, a ruler, pencil, a compass if you have one, but if you don't, that's okay. Just something round that you can. We'll need some tape, some thread or string, maybe not yarn, that's too stretchy, just something like this would work well. A pair of scissors, or if you're crafty like me, then an X-Acto knife. And that's all. So what we're going to be doing today is talking about circles. And to do that, we're going to be, first of all, building a circle and figuring out how a circle is defined. So, like any geometric figure, you start with a point. One point on a plane. And so let's say that we have this point, and we find another point that's 2 inches away from that first point. So we have a point there. Okay? So that distance is 2 inches. Now let's find another point from that same point. That's also 2 inches away. And we'll find another point that's 2 inches away. And another point that's 2 inches away. And another point that's 2 inches away. So as you can see, we can build a lot of points. And all these points are just 2 inches away from the central point. Now what happens if you find every single point that's 2 inches away from that central point? Every single point that exists, well, what would that look like? Well, this is where you take your compass, and if you start and make every single point that you possibly can, what you end up with is a circle. I'll make that darker so you can see it better. So a circle is just a series of points, every single one of which is the same distance from that center point. So why is that important? Well, that means if you take a line from the center point off to the edge of the circle, it doesn't matter where you go or how far you go, a line is going to be the same length everywhere you'd put it. And that's why this is called the radius of the circle. Now, radius is an interesting word. It comes from the Latin. It because it's radius, and it just means the spoke of a wheel. And you can see that a radius does look like the spoke of a wheel. So when you think of radius, think of like a wheel spoke. It starts in the center and goes out to the edge. That'll help you to remember what a radius is. Now, if you take that radius and make it go all the way to the other edge, like this, well, that length is going to be 2 times what that radius is, right? Because it starts off as a radius and then goes in the other direction. It's going to be the same distance, right? Because it's the same distance from the center. And this, all the way across, is called the diameter. And as you can see, every diameter is going to be the same length too, because it's just composed of 2 radii, which is the plural of radius. Now, diameter is a Greek word, and it is a compound word that comes from the word dia, meaning across, and metron, meaning to measure. So diametron means the line measuring across. So if you're finding the diametron, you're finding the diameter. That's the line that's across, that's dia, that you're measuring. So radius, spoke of a wheel; diameter, distance all the way across. Now there's one other thing we need to talk about with circles, and that, now that we've measured from the center out and we've measured from side to side, we can measure all the way around the circle, right? You start from one point, say this point, you start measuring here and you go all the way around until you get back to the same point. So you can find the length of that curved line around the outside of the circle. And that is called the circumference. Now, circumference is a Latin word. It's a compound. It comes from circum, meaning around, and ferry, meaning to ferry, to carry, like a ferry boat. So the circumferens in Latin means to carry around. And so it's that one point, and you're carrying it all the way around the circle. So you're measuring it around. Let's talk about how to find what the circumference of a circle is. Now, it's easy to find the diameter. All you can do is take a ruler and measure it, right? Like this last one we did. You know, we can measure the diameter and say, okay, well, the radius is 2 inches. So the diameter would be 4 inches, right? 2 inches for one radius, 2 inches for the other, so it's 4 altogether. But how do you measure around the outside? Because it's a curved line. It's very difficult to measure around a curved line, right? So what we can do with that is we can do something with a special number called pi. And we'll talk about what pi is just now. So let's take something round. Rather than draw it, I'll just use this and trace it. Okay, so we have a circle, and we want to find out what the distance around that circle is. Well, what we can do is that we can take this bit of thread here, and we can string it around the outside, right? And if we do that, that should be able to tell us the distance around. Because we're going to take that round edge, we'll make it into a straight edge, and then we can put a ruler on it. So we'll put a little piece of tape on the end of that thread and put it right here, and then string that thread all the way around like this. There. And where it meets up again, we'll cut it off. Doop. There. So here's the distance around that circle. And I'll put it down here on the paper. Ooh, a little bit longer than the paper, so we'll put it right here. We'll start it right there, and we'll end it right there. All right, and you want to stretch it tight because you don't want any slack in it, so we can get as accurate a measure as we can. There. So this distance here is how far around this circle is. Now, a long time ago, people found something very, very interesting about the relationship between the distance across a circle and the distance around a circle. And what they found is that if you get the distance from edge to edge, the diameter of a circle, and compare it to the distance around a circle, it's very, very interesting, the relationship that's formed. So, first thing we have to do is we have to find the exact center of this circle. And that's not difficult to do with a compass, because if you take a point like this and you strike an arc on one side, then strike an arc on another point of the circle, you get 2 points. And if you connect those 2 points, they will go through the very middle of the circle. So if you want to find out where the exact middle of that line is, you can do the same thing. Take the end of that and strike an arc from here to there. And take the top point and strike an arc from here to there. And that gives us these 2 points. And if we connect them, we get another line right through the middle of the circle. And where those lines cross is the center point. So each of these 4 lines is now a radius. And the line across the middle, well, that's the diameter. So if you didn't know how to make 2 lines to find the center point of a circle with a compass before, you know now. Kind of cool, huh? There's all kinds of neat geometric things that the Greeks taught us when they were playing around with angles and circles and arcs. So let's figure out how long this is. Let's measure it. And we find out that it is 3 3/4 inches from here to there, right? So the diameter is 3 3/4 inches. Well, if we take the length of that diameter and we compare it up here to our circumference, we'll start at the far end down here and we'll measure 3 3/4 inches, and then we'll make a mark like that. There's one. That's the distance of one diameter. Now we'll do that again. 3 3/4 inches. We go to there. And we'll make a mark here. That's 2 diameters. Now we'll go 3 3/4 inches again, and we'll make 3 diameters. And look what happens. There's a little bit left over, right? There is, what, 1, 2, 3, 4, 5, a little over 5/16 left over. So that's interesting. Let's see if we can figure that out more. Let's do the same thing, but this time let's take that line and we'll put it right here, and we'll measure it with this string. So we know that this string is now the same length as the diameter. So let's run the diameter around the circumference and see if the same thing happens. So we take it from there, and we run it across as best we can. There we go. And that is where the first one ends. So that's our first diameter from here to there. The distance of the second diameter goes from here, and we'll walk that across like this to there. That's our second diameter from here to there. Then we'll run our third diameter around, and it's not going to meet up, is it? Just like before, it is a little bit short. It ends up right there. So the distance from here to there is always going to be left over if you try to wrap the diameter around its own circle. There's always going to be this much left over, or if you over here, that much left over. There's always going to be a bit that's going to be short. And for the longest time, people tried to figure out, what is this little bit that's left over? How much is it? And they figured out through long amounts of trial and error that it was a number called pi. And pi is a Greek letter. It's a Greek letter for P, actually. And they found out that you have to call this pi because if you write it down, it's a transcendental number. It never ends. So the distance around is 3, and then 1, 4, 1, 5, 9, and it goes on and on and on and on and on. We'll just call it 3.14. We don't need to go any more exact than 3.14. So for our purposes, 3.14 is going to be the proportion of the distance across a circle to the distance around that same circle. This means if we know the radius of any circle, we can find out what its circumference is. And if we know what the circumference of a circle is, then we can find out what its diameter is. Cool, huh? So let's do a couple examples, and I'll show you how it works. Let's pull out a fresh sheet of paper. And we're going to use a calculator for this. So let's say that we have a circle with a radius of 1 inch. See, there's 1 inch. We'll draw that circle. There. I'll fill that in so you can see it better. Okay, so this circle has a radius, a spoke, right, of 1 inch. So, if the spoke is 1 inch, that's the radius. What is the distance all the way around it? Well, if we know that the diameter is going to be 2 inches. So if we have 2 inches times, it's going to be 2 there, and 2 there, and 2 there, and that little bit more, right? So if we multiply 2 times 3.14, that tells us that 6.28 is what the distance around this is going to be. And we can check that out, can't we? Because 6.28 is a little bit more than 6 1/4. So let's take this string and measure out a little bit more than 6 1/4 and see if that wraps around. Put it right there. That's where we cut it. There. So if the diameter's 2, then the circumference is supposed to be 6.28, and let's see if it is. As you can see, we wrap it around, and look at that, right on the line. So, yeah, it works, doesn't it? So if we take whatever our diameter is, we'll call 2 the diameter, and 3.14, that's pi, right? The diameter times pi is going to equal the circumference. Now, let's do another one. Let's say that we have a circle, and we don't know, I'm not going to draw this to scale, right? This is just going to be just a random circle. And I'll fill that in to make it more obvious. There we go. There's our center point. Now, if we know that the circumference of this circle, let's say the circumference is 10 inches, right? Our circumference is 10. Then how do we find out what our radius is? So we're looking for our radius. And we can do that because if we know that the diameter times pi is the circumference, well, if we're looking for the radius, we know that the radius is 1/2 the diameter. So if we can find the diameter, we can find the radius. So to find the diameter, we have to take this equation. We got to get pi away from this side and put pi on that side, right? That means the diameter is c divided by pi. Okay, so we can plug those numbers in, right? So if we know that the circumference is 10 and pi is 3.14, if we divide 10 by 3.14, that should give us the diameter, right? So let's do it. Let's take 10 divided by 3.14, and that gives us 3.184. I'll just call it 3.18. So that's our diameter, is 3.18. Well, that's fine, but we're looking for the radius. So we have to find what half, right? That's our diameter. We want to find out what half of that diameter is to get to the radius. So then the radius would be 3.18. You divide that by 2. So let's see. 3.18 divided by 2 gives you 1.59. Now notice what I've done is I've rounded everything to the hundredths place, right? Because since pi is just an approximation here, right? It's actually 3.14159 blah 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 blah. But since we've rounded this to the hundredths place, I'm rounding everything to the hundredths place. That way we don't get more exact than we really need to be because we're estimating pi to begin with. So 1.59 would be our radius. Just a little short of 1 3/5 of an inch, right? That's how you find the circumference given the radius and how you find the radius given the circumference. Now, let's look at something else. Let's say we have, here's another circle. And let's say this circle, there's its center point. Let's say that we don't have a whole circle. Let's say that we just have a half circle. Let's say our circle just goes from here to there. And we want to find out just what this line is here, right? Called the arc length. So let's say we're looking for the arc length of this half circle. Well, if we know that 3.14 is the whole circle, then we know that half of that is going to be for the half circle, right? So if our diameter is about 2 1/4, let's say, so our diameter is 2 1/4 inches across, then how much would just from here to there be? Well, we can figure that out, right? Because we know that the whole circumference is pi times the diameter. Pi is 3.14, and our diameter is 2.25, right? Then, if we did that, we can find that our whole circumference is 3.14 times 2.25, which gives us 7.065, which we will call 7.07. Now that's the whole distance around, right? But we're just looking for half of that. So half of that is going to be half of 7.07. So if we take 7.07 and cut that in half, we divide it by 2. And then 7.07 divided by 2 is 3.535. Now we're rounding to the hundredths place. So that means the distance right here, if this was A, B, C, then the arc length from A to C is 3.54. So it's half of what the circumference would be. So it would be half of 2 1/4 times pi. So there's some fun with circles. And you know what? Let's go a little bit above and beyond. I'm going to do something that's a little bit different. I'm going to push this into some advanced stuff here if you really want to go crazy with this. So let's say that we have, let's make a perpendicular to this line. So strike an arc here, strike an arc there, where those 2 points cross. We make a vertical line there, and that's 90 degrees. We've now made a 90-degree line. So these are perpendicular to each other. Now let's say if we wanted to let's make this 3-inch radius. So we have here a circle with a 3-inch radius, but that only goes up to this point. It only goes up to 90 degrees, right? So we only want to measure this much of our circle, right? That's 90 degrees. So you know how to do that, right? Since you found half of pi times the diameter before, if all you have is the radius, and you know the radius is 3 inches, then this would be 2 times 3 inches, right? That'll get you the diameter, times pi, but you're only finding 1/4 of the circle, right? So you would either divide that by 4 or multiply it by 1/4. And we'll call that arc length x. So 2 times 3 times pi times 1/4 is this length here, if the radius is 3. So, you see how we built this? We just did diameter times pi as circumference, and we just built out from what we knew. We know that 2 times 3 goes from your radius to your diameter. We know that the diameter times pi is the circumference. And we know that this is 1/4 of a circle. So you're only finding 1/4 of pi times the diameter. And that'll give you this distance here. And just for fun, let's solve it and see what it is. And if you want to pause the playback and find out yourself and see if you're right, you can pause it here while I work it out in the calculator. So 2 times 3 times 3.14 times 1/4 is 4.71. So 4.71 is the distance of the line from here to there, if that length is 3. Now, that's fine if this is 90 degrees. I'm going to go a little bit more of a deep dive. I'm going to see how far we can go with this. Let's say that we don't have 90 degrees. Let's say we have 92 degrees. Okay, so let's say that that's no longer the line we're looking for. So we're given that angle AOB is 92 degrees. So what is the arc length now? What is the length of line X, or arc AB? Well, just like you knew that this was 1 part out of 4, how many parts are there in a whole circle if you're dealing with degrees? It's 180, right? And this is going to be 92 degrees out of 180 degrees, right? So just like we had before, you can have 2 times the radius times pi times 92 360ths. Why did I say that was 180? It's not. It's 360 in a circle. Extra points if you caught that. So 2 times 3 is our diameter, times pi, that's our ratio, times how much of a circle that is, will tell us the length of this line here. So let's try it. We'll go 2 times 3 times 3.14 times 92 divided by 360, and that gives you 4.8146 bar. So we'll just call it 4.81. So you recall here, this is 4.71 for our 90 degree, and then 4.81 for arc A to B, if that's 92 degrees. So this is way beyond what we'll be doing in 7th grade. But if you're able to get all of this, then this is your next logical step. So just thought I would show that. The IXL we have is pretty basic. It's just finding circumference if you're given a radius or a diameter, or finding the radius or the diameter if you're given a circumference. And 3.14 is going to be pi for everything that we're doing. And you are, of course, welcome to use a calculator on it. And if you're interested, speaking of deep dives, I'm going to do a little video later on. I'm going to talk about how the ancients figured out what this 3.14 ratio is and how you, at home, can mathematically derive this formula the same way that major scientists did for hundreds of years. So I think that'll be fun. If you're interested, you're more than welcome to check that out. And if you're not, maybe it'll binge your brain a little. So that's the lab for today. Thank you so much. If you've been following along with any of this, feel free to submit what you've been doing. If you haven't been following along, do a couple like this. You know, make a couple circles, come up with a few diameters, come up with a few radii, come up with a few circumferences, and find out, you know, what comes into what. If you want to measure with your thread and show that, you can do that too. Just give me some indication that you're following along with the experiments we're doing here, and I will see you tomorrow. Thanks, guys.